Hey guys, I just wanted to go over some more problems with you for exponents, just for extra practice. So hopefully you are going to be solving these along with me. So the first three problems, we have two numbers that have the same base that are being multiplied. So the rule is that you are going to add the exponents. So even if you don't see an exponent, that means it's a 1. So since we have x to the third times x to the first, our base stays the same. We add 3 plus 1, and the answer is x to the fourth power. The second problem, we have two numbers with the same base that are being multiplied. The rule is to add those exponents. So we're adding 6 plus -4, and that's a +2. So your answer is y squared. The third one, we have two numbers with the same base that are being multiplied. The rule is to add those exponents. So 5 plus -5 is 0. So x to the 0 power, anything to the power of 0 is equal to 1, right? And this would make sense because if we wrote this out, it would be x to the 5th, basically over, because this makes it go down into the denominator. So if we have 5 x's on top, 5 x's on bottom, they would all cancel each other out, leaving us 1. All righty. The next one, let me clear up the screen. The next one is 56.4 to the power of 0. Once again, anything to the power of 0 is equal to 1. The next problem is a division problem. So the rule is when you have two numbers with the same base that are being divided, the rule is to subtract the exponents. So we're subtracting 4 from 15, and we get a +11. So that exponent and that number stays on the top or in the numerator. So the answer is x to the 11th power. The next one, we have two numbers with the same base being multiplied. So the rule is to keep the base. So we're not multiplying those 3's. We keep the base. We add our exponents and we get 3 to the 7th power. Also, if you stick that in your calculator, depending on what the directions say, you might also write the answer 2,181. If the directions say leave it in exponential form, that's our answer. If it wants it simplified all the way, this is our answer. All right, hopefully you guys are getting these answers. So on this one, our bases are not the same. So there's no rule for this one except to literally multiply 2 squared, which is 4, times 3 to the third, which is 27. And then when we multiply 4 times 27, we get 108. All right, the next one, two numbers that are being divided with the same base. What do we do with our exponents? We subtract them. So 10 minus 3 is +7. So once again, you can leave that answer or you can write 2,187. All right, the next few problems, if we end up with a negative exponent, the rule says in order to make that exponent positive, if it's in the numerator, you flip it down to the denominator. If it's in the denominator, you do the opposite. So 5 to the first power would come to the denominator. You can't have a blank space in the numerator, so we'd have to put a 1. And then 5 to the first power is simply 5. So 5 to the negative first is equal to 1/5. All right, same thing with this one. This number is written in the numerator. So to make that 2 a +2, we're going to bring that 6 down to the denominator, 6 to the +2nd. Well, 6 squared is 36. So the final answer is 1/36. Here we have two numbers that are being added. Excuse me, they're being multiplied with the same base. The directions say to add those exponents. So 5 plus -7 is -2. So this would equal 3 to the -2, which is correct, but to be simplified, it has to have a positive exponent. So we would drop that 3 down to the denominator. The exponent becomes positive. You can't leave a blank in the numerator, so we'd put a 1 there. And then we can simplify it one step further because 3 squared is 9. So this answer is 1/9, 1/9. And then the last problem on this screen, anything to the 0 power is 1. All right, a little bit more with division. So on this page, we're going to have 10 x's on the top, 1 x on the bottom. We'd have one pair that eliminate each other. So basically what we would have left is 9 x's in the numerator. So it's x to the 9th, even though I can't write for some reason, x to the 9th. Oh my goodness. All right, the next one, we'd have 15 x's on the top, 3 on the bottom. So we'd have 3 pairs that eliminate. And then how many x's would be left? 12, and they would all be in the numerator. So 15 minus 3 is 12. Here we would have 3 x's on the top, 8 x's on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. These 3 pairs would eliminate each other. And then we have 5 x's left. Where are they? They're in the denominator. So all of our x's are left in the denominator. In other words, 3 minus 8 is -5. So for that 5 to be positive, it would have to go down to the denominator. The next one, we have 2 numbers that have the same base. So our answer includes that base. And then 4 minus 2 is 2. Also, depending on the directions, you could write that the answer is 100 because 10 squared is 100. The next one, we have 12 to the 4th divided by 12 to the 1st. We subtract our exponents. 4 minus 1 is 3. So that's a good answer. Or 12 to the 3rd power is 1,728. All right, this problem. So first of all, we could just subtract our exponents if we wanted to, which gives us -5, which is 6 to the -5th. And to simplify that, we would drop that down to the denominator. We could think of it that way, or we could go ahead and think, okay, well, I'm going to make this positive first. So I'm going to leave my 6 squared in the denominator. I'm going to bring down my 6 to the 3rd power. And then 2 numbers that are being multiplied with the same base, we add those exponents. And so that is the final answer. Either way you think about it, you get the same answer. And of course, 6 to the 5th power is a big number, so you could write that big number in the denominator as well. The next problem we have power raised to a power. This is when you multiply exponents. Anytime you have a power raised to a power, so for example, if I have 2 to the 3rd power raised to the 2nd power, I'm going to multiply those 2 exponents and I would get 2 to the 6th power. Okay, so here I have 4 times 6 is 24. That 1 times 6 is 6. And then I could simplify that by subtracting those exponents. So my final answer would be x to the 18th. All right, this one, we're going to multiply our exponents. So 6 to the 4th over 5 to the 6th. And we would literally do this. We would write this out, put it in our calculator. 6 to the 4th over 5 to the 6th. And my calculator tells me the answer is 0.082944. Or you could write those 2 big numbers and put it in simplest form, whatever those 2 big numbers are. You have a calculator. Oh, that was it. All right, you guys, I hope that helped you. Just a quick review. So you're going to answer some problems today, more on operations with exponents. So you guys have a good day. And if you need my help, if you have any questions, let me know. I'll see you guys later.